Alright, so today we're going to take our sine function and we're going to do the two most basic transformations on it. We're going to shift its period and we're going to shift its amplitude. So amplitude is the very first number that you're going to see. It's our A, and that tells us how high and how low the graph will go. So that affects the y-axis, think of it that way. B, the number that's in front of x, is going to affect period. Period is represented with a capital T, so that's going to tell us that's our period. And you actually find the period by taking 2 pi divided by b, or 360 if you're in degrees, so keep that in mind. What you get out is your new period. Then we're going to do something with that final period that's going to help us to divide our x-axis into the 4 increments that we need. Last thing that we have are reflections, and that's going to be in front of A or in front of B. So if A and B are both negative, they do the same thing, and if you flip it over the x or you flip it over the y for our sine graph, it does the same thing. So it doesn't matter where that negative is, it's just going to reflect it. So let's go through 3 examples that we have. The first one that we're going to do is f of x equals 3 sine of x over 4. So I always, off to the side, I write amplitude and period for right now, and we're going to find those two things. Amplitude is 3. My period is going to be 2 pi over b. Well, b this time is 1/4 because we can write x over 4 as 1 over 4x. So we're going to divide it by 1/4. Well, when you're dividing a fraction, you flip it and multiply. So my new period is 8 pi. When we go to graph this, I'm going to put in my amplitude, so we're going to go all the way up to +3, all the way down to -3. My amplitude is the distance above and below your starting point. Think of it that way. Period is 8 pi. Well, we need 4 intervals, 4 increments on our interval to graph one complete period. So the easiest way to do it is to take your period, so my 8 pi, divide it by 4, and that tells me each tick mark or each increment is going to be 2 pi units long. That means this is 4 pi, 6 pi, and then 8 pi. Then all you have to do is remember where sine starts, so it starts at the origin because sine of 0 is 0, and then it goes up because our sine graph becomes positive. We turn back around through that middle point. At 6 pi, we hit our lowest, and then we turn back around. Connect your dots, and there is your sine graph. Now we have 1/2 sine of 4x, so my amplitude is 1/2. So if I go ahead and put that on my graph, I'm going to go up to 1/2, and I'm going to go down to 1/2, to -1/2. And if you look, it really looks the same as a 3 and a -3. As long as you have those values listed, we know what you're meaning. It doesn't have to be to scale. Then we've got a period. So my b value is 4. So 2 pi over b, or over 4, gives me pi over 2. That's how long it's going to take to repeat itself. So it's going to repeat much more frequently than if we had a period of 8 pi. When we do our increments, I'm going to take my period, so pi over 2, divide that into the 4 tick marks that I need. So that's the same thing as multiplying by 1/4. That gives me pi over 8. So every increment on my x-axis is 1 pi over 8. So this becomes pi over 8, 2 pi over 8, or pi over 4, 3 pi over 8, and 4 pi over 8, or pi over 2. We've got a positive A, positive B, so no reflection, so we start at the origin, and we go up, then down, to our lowest point and back around. Once you have those 4 points, your graph is pretty easy to make. Now we've got our last graph. So amplitude is 2. This time it's negative, so I'm just going to put a little note to myself so I know that it's reflected. Period, 2 pi over 3 is just 2 pi over 3, so that's fine. We're going to come off to the side. I'm going to take my period, so 2 pi over 3, and I'm going to divide it by the 4 increments that I need. So remember, that's like multiplying by 1/4. Tells me each increment is going to be 2 pi over 12 units long. I'm going to go ahead and make that pi over 6. It just makes it easier to work with. So we're going to go ahead, we're going to go 2 to -2 for the amplitude, and then we're going to put in my 4 turning points. Each turning point has an increment of pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. And notice I didn't simplify. That's fine. Start at the origin, but because we have a negative A, we're going to go down to -2 first, then back around. So we're going to go down, up, and around. And that is a reflected sine graph. So here are my 3. If you want to try them on your own, there are some problems that are going to be listed on the next slide, so you can try those.